let's talk about the convergence of real sequences, right? Let us do that using an analogy, right? Let's consider an athlete who's jumping across a ring of fire, right? Now if we see this ring of fire, we can see that it has two parameters, vaguely two parameters. One is the height from the ground, right? The height from the ground, and one is the thickness of this ring, right? Or rather, the diameter of this ring, right? So we have two parameters, and this athlete is going to jump across this ring of fire. Now, if we increase the height of the ring, then the athlete might not be able to jump across that ring, right? But if we decrease the height, then the athlete might easily be able to jump across that ring. Similarly, if we decrease the thickness, or rather the width of the ring, he might not be able to jump. But if we increase the thickness instead, then he is going to be able to easily jump across the ring, right? Now with sequences, we are going to consider a sequence to be analogous to an athlete, and we would call something an epsilon band, and we would find it analogous to the ring of fire that we just saw, right? Now a sequence, we would vaguely call a sequence to stabilize, right? At some height h and at some non-zero width, right? Let us see that using some examples. Now in this example, let us consider this constant sequence of ones, right? Now if I consider a ring of fire, or in this case a band which is centered at 1, which is centered at height 1, and which has a width of 2 units, right? A width of 2 units implies that this is equal to 1 and this is equal to 1. So these two distances are 1 each, right? And for this band, now the band that I would call is going to be infinitely long, right? So I'm going to infinitely extend this, and this is going to be analogous to the ring of fire that we considered in the first example, right? So this sequence, this athlete kind of sequence, is going to jump across this ring of fire. What does it mean? All the terms of the sequence should lie inside this band, right? Now since that happens, this athlete is able to jump at a height of 1 unit and a width of 2 units, right? So he passes this test. But if we consider the same sequence, choose a different height for constructing the band and choose a different width, right? Then we can still see that this athlete kind of sequence is able to jump, or rather contain itself across this inside this ring of fire, or rather the band, right? So all the terms of the sequence lie inside this band. Now let us consider another band which is also centered at 0.75 but with a narrower width, right? So the same center 0.75 but a narrower width. Now since we have decreased the width, right, we are able to see that none of the terms of the sequence lies inside this band. So here this sequence kind of fails to be inside this band, right? But when we saw the first example, right, in this example we considered a thickness of 2 units, right? And this sequence was able to pass that test. But also if we consider this thickness, right, even if we consider this thickness, all the terms still lied inside the band, right? If we consider still a smaller thickness, even then all the terms are going to lie inside this band. So no matter what the thickness of the band is, at the height of 1 unit, this sequence is able to pass, or rather be contained inside this yellow band fully, right? We could say that this sequence kind of stabilizes at this point 1, around the point 1. This sequence kind of stabilizes, right? Vaguely we can say that. But we can also say that this sequence fails to stabilize around the point 0.75, because at a larger thickness all the terms lie inside this band. But if once we decrease the thickness, the terms fail to lie inside the band, as in this example, right? So none of the terms of the sequence lie inside this band. Now for the next example, let us consider this sequence 4 3 2 1 0 minus 1 minus 1 minus 1 minus 1, right? So and let us consider a band which is centered at 1.5 units and which has a width of 6 units. Basically this is the band, right? So this is the yellow band, and now it is easy to see that all the terms of the sequence lie inside this band, right? If we extend this band, now we can see that all the terms of the sequence lie inside this band. But once we start decreasing the thickness, now if this is the thickness, and all these terms don't lie inside this band, right? Only these two terms lie inside this band. But after a point of time, we can find that none of the terms of the sequence lies inside this band, right? So this sequence kind of fails at a height of 1.5 units, right? So this sequence doesn't stabilize around the height 1.5 units. But if I consider the point -1, right, and draw a very wide band, right, wide band of say 12 unit length, right? So 6 units above this point -1 and 6 units below the point -1. So we can easily see that all the terms of the sequence lie inside this band. And even if we decrease the thickness, right, so even if we decrease the thickness, we are still able to find a stage on the x-axis, the stage being 6 here, such that all the terms after that stage, that is all the terms from the 6th term, that is 6th term, 7th term, 8th term, are going to lie inside this band. But we can see here that initially the sequence does not lie inside this band fully, but we can still find a stage such that all the terms after that stage lie inside this band. Now we can vaguely say that the sequence kind of stabilizes after a stage, right? So this stabilization would be called as convergence in mathematics.